So anybody has question on homework on chapter 6? So our exam will be next week, Thursday. Exam is next week, Thursday. Take home problem 6. I put there due on Thursday, on Tuesday the 13th, but it is before class. So just have it in mind that it's like Monday. So if you can make it before Thursday, it will be better, okay? So that we are able to go over take home problem 6 on Tuesday before the exam on Thursday. Today, I want us to go over take home problem 4. I was thinking we can do 4 and 5, but I want to start chapter 7 so that we go on chapter 7 slowly. But there is a lot more in chapter 7 to learn. We are going to do take home problem 4 today and do section 1 of chapter 7. And then take home problem 5 on Thursday. And then we do section 2 of chapter 7. Then take home problem 6 on Tuesday. Then we do section 3 of chapter 7. But exam will be on 4, 5, 6. Do we get this? Exam is 4, 5, 6. But I want you to have the time to work. Please work on those take-home problems. If you have questions, contact me. Office hour link, I'm going to put it on Canvas too. You are going, if you know that it's in my office hour, you just click on that link to discuss with me if you have a problem, so that you don't need to send me an email to get the link. Yes. Next Thursday. What did we say about it? Did we say a date for exam? On your syllabus, you should have the date. It's on next Thursday. Because probability is a little bit much more work than statistics. So that's why I want us to take the time to prepare for that exam. So it's not just for you to forget about 4, 5, 6. It's for you to continue to work on the homework, work on the take-home problem. Make sure you understand what to do when you are asking questions. Take-home problems give you the type of questions I can ask you on the exam. Homework helps you to answer those questions by checking your answers in the book or by asking me how to do it. Okay? So we want to start with take-home problem 4. A card is drawn from a standard deck of cards. What is the probability that the card is a queen, given that it is red? The card is queen, given that it is red. What do you think should be the answer here? Any suggestion? Queen, given that the card is red. So we go into the card and we count the number of red and then the number of queen that are red. So this is number of red and then number of queen and red. This is the formula that you have. So how many cards are red? How many cards are red? 26. How many of those cards are queen? Of the reds? 2. So what should be the answer? 2/26. You can use your calculator to find it in decimal if you like. But when you are expressing answers in fractions, simplify it. Yes. Yes, reduce the fractions or use calculator to make it decimal so that I don't know that you don't want to reduce. If you have the answers in decimal, then I don't know if you want to reduce or not. Then that is fine. That solves the problem. So a box contained 7 red balls, 6 blue balls, and 4 green balls. 5 balls are randomly selected from the box. What is the probability that exactly 3 of the balls are blue? Probability that exactly 3 are blue. It will be equals to number of selections of 5 balls. This is the most general selection. Number of selections of 5 balls. The total number of ways is the number of ways you will select 5 balls. Then the numerator will be number of selections with exactly 3 blue. Number of selections with exactly 3 blue balls. What am I typing? I now don't know what I have typed here. Number of selections with exactly 3 blue balls divided by number of ways of selecting 5 blue balls. Let's start with the number of ways of selecting 5 blue balls. So we will call it n of s. Number of ways of selecting 5 blue balls is what we usually call n of s. Let me just write that, because when I'm typing a lot, I'm typing wrong things. So how many balls do we have in total to select from? 7 red, 6 blue, 4 greens. In total, what will it make? 17 balls, and we want to select 5 out of the 17. So you can use your calculator to find 17 combination 5. Use your calculator. I don't have a calculator here. I will Google for a scientific calculator. The Web 2 is a good one. With Web 2 to find 17 combination 5, I will do 17 combination 5. So this gives me, if you don't have, I think all of you should have calculator. You wake up if you don't get a calculator. It will be a lot of work without calculator. For now, we can use scientific calculator to handle it, but soon it will not be enough. You will need a TI-83, 84 calculator. Or you will use Excel. I will teach you Excel as well, but I know at the end, students that have to choose prefer calculator to Excel. So 6,188 is the total number of ways to select 5 balls out of 17. Yes. On the calculator, you go to, you type 17, and then you will see math. There is math somewhere there at the top left side. You will see MATH. And then you take the cursor to probability, PROB. And then you click 3. You will see factorial is 1, permutation is 2, combination is 3. Then after that 3, you press 5. On the PowerPoint, you will see it. Anybody using calculator, do you know what you get? 6188. Use calculator, practice it. It will be better for you. Now, to have 3 blue balls out of 5, that means the 2 other balls are other colors. So, number, we want now n of e. Is equal to number of ways to choose 3 out of how many blue balls? 6 blue balls, right? You want to choose 3 out of 6 blue balls. And 2 out of the other color. How many other colors? How many are not blue? Out of 11 non-blue. So 3 out of 6 is 6 combination 3 times 11 combination 2. Now you can use your calculator to find 6 combination 3. That is 6 times 5 times 4 divided by 3 factorial. So we will get 20. This is supposed to be 20. 6 combination 3 is 20. So we are going to go back and write 20 there. Practice with your calculator for now, with no pressure. 11 combination 2, 55. So we have 20 times 55. If you don't understand what I am doing, make use of your presence now to ask me, why are you doing that? So what is 20 times 55? So now, the probability, this probability will be 1100 divided by 6188. To make things easy, you can just use your calculator to get it in decimal. Don't leave it this way. It's not simplified. 1100 over 6188. 778. Do you get that? Okay. Yes. N of S is the bigger one, is denominator. N of E is the smaller one, denominator. The answer will always be 0 point something. Okay for everybody? So now let's look at number 3. 2 dice are rolled. What is the probability that the sum is less than 7? The sum of the two numbers is less than 7. We already know N of S when we roll 2 dice. It is always, when we roll 1 die, what do we get? 1 die. How many ways? 6. 2 dice. 36. So we should focus more on a sum less than 7. So we will say E is equal to, one can go with, for a sum less than 7, can we go 1 and 1? Then 1 and 2. Can we take 1 and 2? And 1 and 3. I am assuming that you understand why I can list those outcomes. They are numbers that if you add them, you get something less than 7. And 1 and 4. And 1 and 5. Can I go 1 and 6? It is less than 7. So I will start 2. I assume I have finished with 1. When I start with 1 is first die 1, second any number from the second die that can make the sum of less than 7. Then I go 2. 2 and 1. 2 and 2. If we like, we can make it this way if you like, just to make sure that we know what we are doing, that we have gone to another level. Then 2, 3. Can I go 2, 4? Can I go 2, 4? We can go 2, 4. Then now can we go 2, 5? No. I want to go below and do 3. I can go 3, 4. So how many outcomes do we have for n of e? 15. Do you see what I have done? I just want to reduce the space now. If you are doing it on your paper or somewhere you can write, you can make a table and you will see all the possible outcomes. So n of e equal to 15. Now we are going to write that the probability for a sum of a sum of less than 7 is 15 over 36. If you are on Zoom and you want to speak, feel free to speak. You don't want to feel like you are just watching. Otherwise, no point to be on Zoom if you don't want to speak. If you want to speak, you just unmute yourself and speak. And if you have an answer to any question we are asking. Any questions so far? Number 4. At a particular school with 100 students, 34 play football, 23 play basketball, and 7 play both. What is the probability that a randomly selected student plays neither sport? Let E be a randomly selected student plays neither sport. So he doesn't play football and he does not play basketball. That will mean he does not play, he plays neither football nor basketball. That is the opposite of all, playing football or basketball. So we are going to say that the probability that the student play football or basketball is equals to number of students playing football plus number of students playing basketball minus number of students playing football and basketball divided by number of students. So number of students playing football is 34. The total number of students is 100. I'm just typing this. So it's 34 plus basketball 23, both 7. That is the addition rule that we learn. So what does this give us? 50 over 100. It happened that this works out like 50-50. So the probability of E, which is the opposite, equals to 1 minus probability of football or basketball, which is 1 minus 0.5. Because of the or. When you say football or basketball, it's either football or basketball. When you say neither, it's the opposite of the or. So we say that the complement rule, 1 minus the other side, is the complement. Yes, yes. Because those 7 are you counted already as football players. That is, among the 34 football players, there are 7 who are playing basketball. Among the 23 basketball players, there are 7 who are playing football. That's the meaning of 7 play boats. Any other question? We really learn when we are asking questions. Can we move? Any other question? Okay. So here we need to complete this table. You will need calculator here. So here I know should be 100. So we can complete this one as well. So to complete this, you want to say 46,800 minus 4,800, because 100 plus 4,700 will give you 4,800. So what should we write here? Yes. 42,000. Is that okay? Okay, now what should we write here? 10,000. And here? 53,200. If you don't know where we are getting these numbers, just ask. That's what we are doing. So the total will be what? 100,000. So A, find the probability that a pattern selected at random is made in the United States and it was issued to the government. Here is an, made in the United States and issued to the government. So that probability will be, I'm just going to use letters, okay? Probability of the United States and government equals to n over n. Here, the first n below is the total. Is the total, because we can count the United States and government divided by total. So this is United States and government. So what is the number for United States and government? 900, and the total 100,000. So this gives us 0.009. Good question, because the probability of an event is number of outcomes in that event divided by the total. So that event is United States and government. We count the number of United States and government and divide by the total. Let's get this one first. So now we will compare it to the next question. To understand what we have done, here we should look at the next question. That is where the confusion comes from, generally. Given that a patent was issued to the government, what is the probability that it is made in a foreign country? Given that, it's not the same as an. You already know. The first one, you don't know. You just know that it is made in the United States and issued to the government. How many? So this one, we are going to write it as probability of, what is the probability that it is made in a foreign country? Foreign country, given that it was issued to the government. So I cannot count the number of F given G. That kind of event is not like you can count it. It is conditioned. So more than that, what we are going to do is that we will write it as, because we already know that it is issued to the government, we just count the number of patents issued to the government and find out from those ones how many were from foreign countries. Do you get the difference between the and the given that? So we are going to do this. Now this one is n of foreign and government divided by government, because it is known that it comes from a government. So we now count foreign and government, how many? Foreign and government, how many? 100. And then government? So next, yes. Made in B. If is that's the condition. That's the expression of it. So, but I stick on giving that so that I don't give you another type of questions and you get confused. If I say, if issued to the government, that is still a condition. The probability you want to find is, find the probability that it is made in a foreign country. If you say given that, or if it is still the same thing, it's conditional. Any other question? So what is the probability that a patent was either made in a foreign country or was issued to the government? So here is probability of the patent was either made in the United States, U, or G, which is equal to, oh, foreign, thank you. In a foreign country or was issued to the government. Because or is a combination of events that we know. This will be N of F N of S is for total. That's just the basic definition of probability as we learned at the beginning. So this equal to, I do this just to ease my typing. So N of F plus N of G minus N of F divided by N of S. How many were made in a foreign country? Foreign country. Foreign country, 46,800. Government, 1,000. Foreign country and government. So what is this equal to? This equal to the numerator will be 47,700 divided by 100,000, which is 0.477. Okay for everybody? In a small college, it is known that 80% of students have a smartphone. 3 of the students are randomly selected. What is the probability that all 3 have a smartphone? Because 3 are randomly selected, the probability of all 3 is equal to, what is the probability of having a smartphone here? 80%, so we are going to do 0.80 times 0.8 times 0.8, which is equal to what? Yes. Anybody has an answer? 0.512. Anybody has a question about that? Now, none has a smartphone. Probability for none. What is the probability not to have a smartphone here? What is the probability not to have a smartphone? 0.2. And what should this be? 0. Is it okay for everybody so far? Okay. At least one of them have a smartphone. At least one of them have a smartphone. If E is you don't really need to write all this if you are doing your exam, but I'm writing because you will use it to prepare for your exam. So then E complement will be none has a smartphone, which we know is the answer in B. So now we know probability of E equals to 1 minus probability of E complement, which is 1 minus 0.512. What is the answer? Zero point. Yes. Thank you. So you should be looking at what I'm writing. 008. Thank you. Because I'm getting tired too. 1 minus the none. Do we get that? So what do we get there? 0.992. Then we are done with take-home problem. Sorry, take-home problem 4, which is the first of the 3 take-home problem we want to do. We took so much time. Why did we take so much time to just do one take-home problem? Because I keep typing, I think. Maybe I should type it all before we do it next time. What about that? Somebody think when I type and you are looking, is it not even confusing? Because I type wrong things. So I will prepare the take-home problem 5 before we come on Thursday. So we will not do chapter 7. We will just, I will type, making sure that 30 minutes will be enough for us to do take-home problem 5. I will actually put it on Canvas, but we will still go over it because so that if you have questions. Okay. Do you have any question? Don't say just. Some people might not come. We are going to go over take-home problem 5, quicker than today, so that I teach section 1 of chapter 7. Then on Tuesday, we are going to go over take-home problem 6. Take-home problem 6 will have a lot of explanation. Based on those who come to my office, I see that there is a lot to explain. So do it. If you don't do it and I explain, you will think that you know, but you have not understood. But if you do it, you will know the things that you don't understand. And as I'm doing it, we are doing it together. Actually, you will have questions and you will understand better. And you will be ready for 100% for the exam. Yes. Let me check on Canvas and on syllabus to be sure there is no problem somewhere about this, because I have had a lot of questions about this exam. I want to understand that it is because I am giving you a lot of time before the exam, but exam 2 is October 15, right? It's on Thursday. Okay? So I didn't get it wrong. But you can also see it on Canvas. Okay. So this is where you come for office hour. If it is office hour, you click here. If it is class, Zoom class, you click Zoom class. Office hour, you click here. If you don't get me, send me an email. Yeah, I'm sleeping. Sometimes no student is coming and I'm there working. So email is not good. I just want to make fun. Email is not going to wake me up. But sometimes I'm really distracted and I keep checking my email and check if anybody is. So if you don't see me, send me an email. But I will be there waiting. So this is how you get to. Now, where is exam 2? Okay, exam 2 is here. We've noted. No content. Okay, maybe that was the reason for the confusion, but exam 2 is on week October 12. So we are going to put it here so that if you are checking, you can see it's October 15 for now. I'm going to fit it to fit the time. Any other question? So We are planning that we do take-home problem 4 this Tuesday, take-home problem 5 on Thursday, take-home problem 6 on Tuesday next week. Okay? Because I know how probability is a little more challenging than statistics. So that's why I put so much time for reviewing. Okay. If you have a question, you can still stay and ask. Otherwise, you are free to sanitize before you leave.